Alright, welcome back everyone. This video is the second part of friction. If you missed the first one, I'll suggest you to go watch it. So in this video, we're going to be talking about one type of friction, specifically static friction. I'll be talking about kinetic friction in the next video. So let's define what static friction is. So static means no movement. So it means it's the amount of friction that you have to face when you're moving something, when you're going to start moving something. Now, the mu sub s is always greater than mu sub k. What this means is the kinetic coefficient of friction for static is always greater than kinetic. Now that makes sense, right? I mean, we all know that. Simple. Not really. It's not that intuitive. Now a really quick example is if you have, a closet and you're trying to move it across your carpet or floor or just trying to get it move across something. Have you ever noticed that it takes a little bit more strength, force in this case, to get it moving forward than it actually takes to keep moving it? So if you're pushing this, right? Pushing with both hands, and it takes a little bit more force to get it moving than it actually takes to keep moving, right? Now the reason for that is because of this. So mathematically, you guys don't need to know the derivations or anything like that, but just know that the static is greater than the kinetic. So what it means, you need more force to move something rather than to keep it moving. Now I'm gonna give a quick problem. So you are asked, usually problems asking this are two parts. Number one, let's say you have a 10 kilogram furniture and the coefficient of friction for the floor or carpet, kinetic one is 0.30 and the static is 0.5. Alright, now part number one is the force applied by the human, which I'm going to say 50 newtons. Is this force enough force to move the closet? And the second part, which we're going to do in video number 3, if so, what's the acceleration? It's the acceleration that our closet will feel. Alright, so let's tackle number 1 here. So first of all, let's draw a free body diagram from here. Right? We know that the force of friction, let me switch colors, we know that the force of friction is going to oppose our movement, right, from video 1. We also know that going downwards you have mg, and from our previous videos, Fn goes right up the top, perpendicular to the surface. Now, from our past video, we know that normal force is equals to mg for any horizontal surface, right? If you don't know how this derives, just go back to our previous video. Now, what we're gonna do is we're gonna do Newton's second law over the x. So sum of the forces over the x equals ma, right? Now, what are the forces and is there an acceleration? That's what we're trying to find, right? So before we do this specifically, what is one of the prerequisites? Like reality check. This force has to be greater than the force of friction, right? It makes sense because if we're not applying enough force, our object won't move. So now we need to find what this force of friction is before we are able to do Newton's second law. So now, according to video 1, our force of friction is normal force times the kinetic, well, not kinetic in this case, but our mu sub s, right? Static, because that's the static. We're trying to overcome the static to get it moving. So now, from our previous video, we know that normal is mg times mu sub s, right? And then mg is going to be 10 kilograms g is going to be 9.8 meters per second, and mu sub s is 0.5. Now, I would suggest you pause this video, plug this into your calculator, and you should get 49 newtons. Alright, 49 newtons. Now, is 49 greater than 50? Yes, right? So that means that it will move. So is it enough? The answer is yes, right? Because 49 is less than 50 and the person is applying 50, so it means it will move. What will be the circumstance where we have to say no? In anywhere that the force of friction is greater than the force being applied on the object. In that case, this answer would be no. Alright, so now in the next video we'll find what the acceleration is using Newton's second law, and notice how a lot of people would just go straight into Newton's second law, but reality check, you have to just find the force of friction. Is it greater, equal to, or less than in order to respond number 1, and then you can move on to number 2. So find force of friction first, compare it to the force being applied. If it's less than or equal to, then that means your object is moving. If it's greater than, it means your object is not moving. And then proceed on to do Newton's second law to find the acceleration, which is what we're doing in our next video. So that's all I have for you on this video. Remember, leave us some comments, what you want to see, what you would like to know, and remember to like us on Facebook and subscribe on YouTube. Good luck on your studies.